Arduino is often the first name that comes up when beginners think about learning electronics or embedded systems. Its user-friendly interface and vast online community make it seem like the perfect starting point. But is it really the best choice for those just beginning their journey? In this video, we'll explore why starting with Arduino might not be ideal for everyone, especially if you want to build a solid foundation in embedded development. Let's dive into the hidden challenges and limitations that beginners often overlook when choosing Arduino as their entry point. One of Arduino's biggest selling points is its simplicity. With just a few lines of code, you can make LEDs blink, red sensors, or control motors. This ease of use is fantastic for quick results and instant gratification. However, this simplicity can also be misleading. It hides the complexity of what's really happening inside the microcontroller, making it easy to miss out on essential learning opportunities. As we move forward, let's see how this simplicity can actually become a barrier for deeper understanding. You use Arduino, you're often working with simple functions like digital write or analog read. These functions make it easy to control hardware, but they also hide the underlying mechanisms of how microcontrollers operate. You don't get to see how registers, bits, or memory are managed. This abstraction means you might miss out on understanding the core principles that are crucial for advanced embedded development. Let's look at why this matters for your long-term growth. By relying on Arduino's high-level functions, beginners often skip learning about the fundamental building blocks of embedded systems. Concepts like bit manipulation, register configuration, and memory mapping are essential for anyone who wants to work professionally in this field. Without this knowledge, it becomes much harder to transition to more advanced platforms or troubleshoot complex issues. This gap can slow down your progress as you move beyond basic projects. While Arduino is popular in the maker community, and for prototyping, it's rarely used in real-world industry applications. Most companies prefer microcontrollers like STM32, ESP-IDF, NXP, or T for their products. These platforms require a deeper understanding of hardware and software integration. Professionals often work directly with bare metal code or real-time operating systems, which demand a solid grasp of low-level programming. Let's see why this industry preference matters for your career. Professional environments, developers use advanced tools and platforms that offer much more control and flexibility than Arduino. These tools allow for step-by-step debugging, real-time code analysis, and direct hardware access. By starting with Arduino, you might miss out on learning how to use these industry-standard tools, making the transition to professional development more challenging. Understanding these differences early can help you make better choices as you advance. Arduino's ecosystem is rich with ready-made libraries that simplify adding new features to your projects. While this is convenient, it means you rarely need to write your own drivers or understand how hardware interfaces like I2C, SPI, or UART actually work. When you encounter a situation where no library exists, you might find yourself stuck, unable to move forward. This reliance can limit your ability to solve unique or complex problems. Many beginners never learn how to communicate with hardware directly because they rely so heavily on Arduino libraries. For example, protocols like I2C, SPI, and UART are often used through pre-built functions. Without understanding how these protocols work at a low level, you may struggle to troubleshoot issues or develop custom solutions. This can be a significant roadblock as you take on more advanced projects or work in professional settings. Debugging is a critical skill in embedded development. With Arduino, your main tool for debugging is serial print, which only allows you to check values by printing them to a console. There's no support for step-by-step debugging, breakpoints, or live variable inspection. This makes it much harder to find and fix bugs, especially in complex projects. Professional tools offer far more powerful debugging capabilities, which are essential for efficient development. Building real products, being able to find and fix bugs quickly is crucial. Arduino's limited debugging tools can slow you down and make it difficult to identify the root cause of problems. In contrast, professional development environments like STM32Cube IDE, Kale, or MPLAB provide features such as real-time code monitoring, breakpoints, and memory inspection. These tools help you catch issues early and improve the quality of your code. Professional tools allow you to watch how your code runs in real time, pause execution, and inspect variables or memory. This level of control is invaluable for diagnosing complex issues and optimizing performance. With Arduino, you miss out on these advanced features, which can make a big difference as your projects grow in complexity. Learning to use these tools early can set you up for success in more demanding environments. If you start with Arduino and later want to move into professional embedded development, you'll likely face a steep learning curve. Industry-standard platforms require a deeper understanding of hardware, software, and debugging tools. By skipping these fundamentals early on, you may find it challenging to adapt to new environments or meet the expectations of employers. Building a strong foundation from the start can make this transition much smoother. Metal programming means working directly with the hardware, without the abstraction layers that Arduino provides. This approach gives you full control over the microcontroller and helps you understand how everything works under the hood. While it's more challenging, it's also far more rewarding and prepares you for real-world applications. If you want to become a professional embedded developer, learning bare metal programming is essential. Registers and bits are the building blocks of microcontroller programming. By working directly with them, you gain a much deeper understanding of how your code interacts with the hardware. Arduino's abstraction makes it easy to overlook these concepts, but they are crucial for advanced development. Mastering registers and bits will give you the confidence to tackle any embedded project, no matter how complex. One of the most valuable skills in embedded development is the ability to write your own hardware drivers. This means you can interface with any device, even if no library exists. Arduino's reliance on pre-built libraries can prevent you from developing this skill. By learning how to write drivers from scratch, you become much more versatile and capable as a developer. Many professional embedded systems use real-time operating systems, RTOS, to manage complex tasks. Arduino doesn't provide much exposure to RTOS concepts, which can be a disadvantage if you want to work on advanced projects. Learning about RTOS early on will help you design more robust and efficient systems and make you more attractive to employers in the embedded industry. Debugging is more than just fixing errors, it's about understanding how your system works and identifying ways to improve it. Professional debugging tools give you insights that are impossible to get with Arduino's basic serial print method. Developing strong debugging skills will save you time, reduce frustration, and help you deliver higher quality products. Starting with a more challenging platform might seem intimidating, but it pays off in the long run. By learning the fundamentals of embedded systems, hardware interfaces, and debugging tools, you'll be better prepared for any project or job opportunity. A strong foundation makes it easier to learn new technologies and adapt to changing industry trends. As an embedded developer, I started my journey by diving deep into the fundamentals. I learned how microcontrollers work, how to program them at the register level, and how to debug complex systems. This approach was challenging, but it gave me the skills and confidence to tackle any project. My experience shows that while Arduino is a great tool, it's important not to rely on it exclusively if you want to become a true professional. If you're just starting out, don't hesitate to seek guidance from experienced developers or join communities focused on professional embedded development. There are many resources available, from online courses to forums and mentorship programs. Surrounding yourself with knowledgeable people can accelerate your learning and help you avoid common pitfalls. Arduino is a fantastic tool for quick prototyping and learning the basics, but it's important to recognize its limitations. If your goal is to become a professional embedded developer, consider starting with platforms that offer more control and expose you to the core concepts of hardware and software integration. By building a strong foundation, you'll be better prepared for the challenges and opportunities that lie ahead in the world of embedded systems.